Okay, so I have everything set up. So I have the YouTube comments and the TradingView comments. So yeah, so I'm going to explain to you what we are going to do today. By the way, have I set up education? Because this is mostly education. Have I done this properly? Yes, education. Okay, so yeah, so the idea is to make a strategy out of the Capissimo kNN ideas, because I want to backtest it. Okay, and from time to time, if I update recursive Zignaly template, I will have to update this also so that it matches this recursive Zignaly template. But otherwise, this is the idea. So I'm going to show you what I want to take a look at so that we know what we are doing. So so I have searched for machine learning, and I have find out on the first page a lot of stuff related to kNN. Okay, and there are some strategies that are quite promising. So there's the original one, the new one from kNN, and here there is an example and many other strategies. So I want to write down every one of them so that we have them here. So this is the original script. Okay, then we have okay, let me check if everything is okay with the audio. Yes, it is. Okay, so the other one we want to take a look at is this one here, which is the updated one. Okay, updated original script is this one. Then we have possible application plus library. We have it on this other URL. Where the hell is this? Here. So here we have a strategy which is kNN, and these two indicators FMFI, which I'm not sure what it is. Then ADX, in order to predict stuff. So we already have a strategy that works there. So first of all, okay, so first of all, try to understand kNN a bit, explore if the library is worth using it, and so on. Okay, why is this set on? Okay, so let's go and try to check all of this stuff. So the first one is the original one, which will help us to understand what this is all about, because I have read about it, but you know, it's never the same thing. It's never easy. So Forex and crypto. Okay, so apparently this means nearest networks. Okay, so maybe we should copy this here so that we have the right name. Okay, let me, here there is. Okay, so apparently you have a prediction if it goes up, if it goes down. Okay, and he uses 3 arrays: feature 1, feature 2, and directions. and whatever. Then you can see how this was featured here on the editor specs. That's why I'm taking a look at it. And let's take a look at its source code. As you can see, we have some inputs here, which is where you start, where you stop. I already have these settings on my template. Which indicator you want to use. So you can choose between RSI, ROC, CCI, volume, and all. The short window, maybe the short window is for the future, and the long window, oh yeah, short must be for short in and long for long in. And you can see how you've got the number of neighbors, bars you need to learn, I guess. So here there is some constant to decide if you want to buy or not. And training data, okay, to 100. Result data, signals, some functions to help with all of this. Okay, so these are indicators, long and short. RSI, CCA, ROC, minimax. What the hell is this? Yeah, okay, so depending on the indicator, you use one thing or the other one in order to get these values here. That's this is a function, well, not a function, but so if we are in a training period, then you push stuff into the arrays, and then you do some stuff here. Yeah, this is pretty long. And then finally you've got these other conditions, which should help us to understand. So a start a long trade and a start short trade is about that the signal has changed into buy and the signal has changed into sell. Yeah, okay. Then we have some testing here, and this is a manual backtest to know if this is working right or not. But this is we should use a strategy for this. So we could translate this easily. So let's write down here. We can use original script, other condition calls to know when to long or short. Okay. Now let's take a look at the new script. Okay, this was the old script, and here we have the new script. Wait a moment. This one here. So the new script explains again what the hell is kNN input something. But I'm not sure if this loops always to try to, if it learns always, or if it only learns at the start. So this is kNN, which now it's a function. Now it's using new float, and this is version 5, which is better for us because we code in version 5. Okay, so here you can see how well distance and so on. We also have the prediction function which outputs a prediction, a direction. So prediction is which are going to be the new networks, and then the direction is, are we going up or down. We have some functions for the colors, and finally we have this logic about testing rep, which I'm not sure what the hell that's rep. Okay, rep, non-repainting. Yeah, we don't want to repaint. We have to request security and the time frame, which is the resolution you want to use. Yeah, why would you have resolution so that you can work in lower time frames? I mean, I don't want to handle this stuff about the petition. So you have basically you do an kNN, then you predict with this kNN and C, which is C is the close, and that's it. So the close, this, okay, let me see. This close is returning pret there, which is the direction. And here we have this stuff here. So add-on, set the score, pivot point. What the hell is this? So we've got different colors depending on the direction. So apparently you've got this so depending on the set the score color, you've got some colors of the other ones. Oh my god. So this is very difficult. I mean, this is mixing colors with long and short advice, and this is not good. This is not a good way of doing stuff, because then you don't understand anything. So this is the curve CLR, which I guess it's the prediction as you go up or down, and here you've got the prediction. So P-red. So what we have here is this prediction here in red, okay, and yeah. So I'm not sure if this is useful at all, if you ask me, because I want to know which are going to be the prices in the next step, and I'm not sure this is working properly. Okay, so here we have this function. Okay, so let's write down. So updated original script. We need to break down direction advice from the different indicators so that it's easier to understand when to go long and when to go short. Okay, because right now this is a piece of shit. In order to understand what the hell are you supposed to do, this is the CLR. What the hell means CLR? We don't know. Okay, color, maybe it means color, you know. Undetermined type, yeah, because you don't say anything. So yeah, this is a color, but the color depends on the pivot color. So this is, if it's green, then you go up, and if it's not green, then you go down, and that, yeah. Score. Okay, so so we need to break down the serial variable. Okay, that's the idea. Okay, what more can we learn from this script? One interesting thing is that there's someone here. Wait, isn't it here? Or maybe here? Where the hell is the library? Damn it, there was a library here. Someone who said, hey, I've got a library for you if you want to use it. Okay. Okay, so this is a piece of advice that we could use. Okay. But I don't know if it's worth it or not. Okay, so this is the this is a piece of advice. kNN function can be improved, but using bar arrays, which I am not sure. So you don't have to loop. Then apparently you can call security on the kNN method, but I don't want to call security if you ask me. However, we should be able to. Okay, the library is somewhere else. Okay, so let's take a look at the latest script that we have in TradingView related to kNN. Okay, so kNN, it's here. So here we have another script, okay, which probably is quite good, although here there is a lot of drawdown. But I mean, the way I see this machine learning stuff is that I do not want to code anything. I want something that works always. Okay, so risk reward ratio, something. kNN minimum difference. Okay. Okay, so Last Guru. Okay, so Last Guru is the one who has the library. So then it makes sense. This is the kNN library. So we will take a look and see if it's any of. This is the possible application script. This is the associated library. So what we need to do is we have to compare all of these functions. So kNN, so on. So I guess that do kNN. Yeah. So what we have to do is we have to understand what the hell this script does. So yeah, apparently this script does not use the function that he used. So here you can see some functions here, but then yeah. Okay, June 28th of June 2021. This is older than what Capissimo did, so I'm not sure. Yeah, I'm not sure what we can do here. So let's take a look. Okay, so this is a library, and do we have anything else? No, we have this old one from 2021. We don't have anything else better from this guy. So I think we should take a look at the original library from I mean the improved one, and we should compare it to whatever we have in the library to understand if we can do the same thing, because here we have the kNN data. So kNN and predict. What the hell is this ADH? Adjust prediction. Oh my god. This is going to be some distance get store percent store. Matrix float. Why would you want to store a matrix? Parameter 1, parameter 2, price result. Okay, so it seems that we have some work to do. So we should probably work with this strategy and try to work around whatever. What the hell? Wait a minute. So if I understand well, what this strategy does is filter length. Not apply. Apply kNN filter. So what this does is that you need a crossover between the fast MA and the slow MA for this to work, and at the same time, not apply, at the same time you need the filter to be bigger than the distance. Yeah, kNN. If it's smaller than the negative distance, then it means that we need to go long. So I guess that you save good data thanks to these filter. Then the filter needs to match whatever. What the hell is this? Is this an input? Yeah, let's. When dist is 0, kNN default was 23. kNN minimum difference. Okay. By default, this is 2. Okay, so let me try to understand long condition, short condition. Why would you save something when there is a MA crossover? You save the old data so that you can predict a crossover later? This does not make sense. I mean, yeah, I do not understand how this works. Civil application doubt. Why saving data to the kNN is useful at all? Why saving data to the kNN when the MI's crossover is done is useful at all? Okay, so apparently the it's not used anymore. Apparently the kNN is not used anymore. Okay, let's try to write what long and short. And why do you save long condition here and short condition to here? This does not make sense. Yeah, because the distance. Yeah, more questions. Apparently, the kNN is not used. Apparently, the kNN does not predict anything because you need an MA crossover nevertheless. So this does not make sense to me. Okay, then you have another thing that doesn't make sense to me, which is let me see. Yeah, I mean there's a distance, so apply is if you want to test long and short, then you've got the distance. So so filter is this thing here. ADX, FMI, kNN, SRC. What the hell is this using the saving stuff? Okay, here it is, the bar. That's why. Got some bar values here into the arrays, and then you get the arrays to get new data. Okay. Currently the kNN does not predict anything because you need an NA crossover nevertheless. Does not make sense to me. Yeah. And I don't like how this is saved inside using global variables instead of using yeah, instead of using them from the outside. Okay, so another question. Why don't we have a separate memory for long decisions and a separate memory for short decisions? I mean, this does not make sense to me. Okay, so if long condition or short condition happens, then save anything into the kNN store. So you save the ADX, you save the FMI, which is kind of RSI, and you save SRC, which I guess it's OHLC. Let me see, or maybe it's the input. Let me highlight it so that we can see it somewhere. Yeah, it's the input which is open. Okay, so instead of close, it uses open, which I guess this. Right. So this is using open, you know. That way it doesn't have to deal with repainting, I guess, but I am not sure. So these are the things that I am learning from this third script. So now I'm going back to the first script. I mean, not the first one, but the second one, which is the new approach for kNN. Let's see what happens here with long and short. Do we have a logic for long, another logic for short, or not? So yeah, so the idea here, I think, is that you get the nearest networks, and then thanks to the predict you can say if you go up or if you go down. Okay, so so you don't need to know if it goes up or not. So the explanation is, so replay, we don't need it because predicts the next candles. No need to save different memories for long short. So what this script does is to make kNN learn. So what this script does is to make kNN when there is an NA crossover, and does not matter if it's going up or down. This is a useful moment to remember. I think this is the idea, that what the hell is this? So so if you take a look at here, where we have this kNN store. Okay, this kNN store happens when there is a movement, and we are going to take a look at kNN store, and we can see how store the previous trade, buffer the current one until results are in. So here, the previous trade. What? So this is saving the previous trade. Okay, so this is saving into these different arrays, which are float arrays, something. So it's saving parameter 1, parameter 2, and the price, which is src, probably open. And we have another variable here, which is saving somehow the direction. So if the current value is higher than the previous candle, then this goes up, otherwise this goes down. Then finally you save this as the old value so that you can use them later. That's why these are bar variables. That's the trick that he who must not be named was giving Capissimo before. Okay, the about using bar arrays, then yeah, then you can avoid the loop. So probably this is the trick to avoid the loop. So this is saved into a memory, an array, and my only complaint is that this is only run when we have long and short conditions. So when there is a crossover, you save the previous value on the next one, and so I guess that it's easier to filter crossovers that are good ones or not. Yeah. So why do we have any of the rest of the stuff? Because here we have FMI. Okay, so we save ADX and FMI, which is an RSI based value. So we save ADX, we save MFI, and we save the open value. And then this helps us to decide if we need to go up or not, depending on the old values. So we should probably have some time to learn how this happens before doing anything, because here you can see how it doesn't go very well, but then everything else is perfect. I mean, not perfect, but this is because you have not wait time enough for this to work. Yeah. So here you have how you make a prediction. So we should probably work with this script even if it's older than the original one. I think I like this script better because I understand it better. It has much less functions, okay? So we should probably use, let's see, what's the name of this thing? Because space because it's easier to understand. Okay, so this is 90 to 14. It's not very good. This is 6. So it's 6. So it could be better if we do this, if you ask me. So we could play a bit with this. But I am a bit concerned about the library. So here we have a library, which we don't know how to use it. But it's supposed to be better than what we had before, because here it works with a matrix. And yeah. Okay, so here you have the kNN store, which stores the previous trade. Buffer the current one, and results are binary up down. Store %, get the neighbors, get the distance, sum, and do this thing here. Execute the filter, which says if you want to go long or short. Okay, let's try to read what we have here. So long condition, short condition, and then you've got the feature 1 and feature 2, which is whatever you have in the last one. So we should probably rewrite this with the function and with the library, and then once you use the library, we can yeah, look at that. Okay, so maybe, so this is a strategy. Okay, so it doesn't work with what I want to do. So possible plan. Rewrite this thing so that it has nice parallels. Then we've got this, rewrite this thing again, so that it uses the library functions. And probably recreate the kNN library, because I want to have my own library just in case everything explodes. I have it there. Okay, let's take a look at the library again. I need to download everything to my computer, because otherwise it's very difficult to compare one stuff and the other one. Okay, here we have some explanation about this. So the wrapper, yeah, so the wrapper is this one here, isn't it? The wrapper is do kNN. Support the function do kNN. Okay, let's read here what we can do with this. So to make a kNN prediction, we need to supply the wrapper is the filter types is binary or percent. Okay, so binary works like the original script, which means that you know if the price has increased or decreased since the previous kNN store event when its long or short condition is applied. Percent works the same, but the values stored are the difference of prices in percents. That way, larger difference in prices would be higher scores. Okay, look at that. Okay, this is how many nearest neighbors are to be selected and sum up to get the result. So this is something that we need to find out. Skew, kN minimum difference. Yeah, def, matrix. Originally, the whole unbelievable story of trade was used to make a prediction. This not only requires more computational power, but also neglects the fact that market conditions are changing. This setting restricts the memory matrix to find. Oh yeah, that's right. That's what you have to do. Restrict the memory matrix to a finite number of pass trades. Okay, true if the long conditions are met, but filters are not yet applied. For example, my original script trades are only made of crossing fast and low MAs, so whenever it is possible to go long, the value is set to true, false otherwise. Short condition, same as long, but yeah. Store, whether the input should be stored. Additional filters might be applied to prevent bad trades. For example, trend-based filters. So if you only need to consult kNN without storing the trade, this should be set without storing. This should be set to false. Okay. If you consult, this needs to be set to false. So feature 1. Feature in this case some kind of data derived from the price. Different features may be used outside the price areas. Oscillator values. Only 2 features can be used. Okay, here we could add more features if we want, but I am not sure. Future plan. Add more than 2 features, if it makes sense. Okay. So the proper returns the tuple long OK, short OK. This is a pair of filters. When long OK is when long OK is true, then kN predicts a long trade may be taken. When short OK is true, yeah, then it's short. kNN filters and return whenever long and short conditions are met. The trade is supposed to happen when long and short conditions are met, and when the kNN filter for the desired direction is true. The trade is supposed to happen when long or short conditions are met. Yeah, this is what he has in his original script. So exported functions, you have many of them. Why would you have so many of them? Don't you only need the wrapper here to put some stuff there? Maybe not, because you want to be able to use everything here manually. Yeah. Okay, so we have some work to do. We also want, okay, so rewrite this so that it has nice variables, recreate the kNN library. Yeah, and what I want to do is add a learning period when you do not perform any trade, so that kNN is able to learn. That's right, because right now this is not working properly. Yeah. So that's it. I think I'm going to end here. We'll probably work on some other stuff later, but this is what I want to do. Put some nice variables, ignore functions because we are going to update them with the library stuff, okay? And then yeah, and then probably this library can be improved somehow, because I don't know, why would you have a matrix? Okay, maybe we can set matrix. Maybe we can set the matrix from the outside with some settings, and or using, what's the name? Using types, and then yeah, I don't know. Maybe we can make this more scalable by using matrix and so on. So we don't have any comments in this strategy. Let's see what happens with this one here. Do we have some comments that are useful for us or not? Risk reward ratio, so we will have risk reward ratio. Yeah, kNN votes. This is a library. And then you've got negative quantity, which is when you don't have enough quantity. Okay, so the idea is to learn from here and then you go up only, or learn to here and then you go up only, or something like that, but I'm not sure how much to learn. Probably learn 1000 traits, as some people say, but I'm not sure about this. Not 1000 candles, but 1000 crossing M's. You know what I mean? Okay, so let's end here the stream. And next video we will be able to know what we do here. Okay, so right now we have 1 hour. Okay, 1 hour. So next video we will do this. Hopefully it's good enough. So thank you very much for being here. Hopefully you have learned something from me. And this kNN stuff is nice. If it works as expected, it's going to be very nice. Let's end here the stream. Bye.